Good evening, algebra students. I hope you're having a good day. Today we are continuing in Chapter 5, and this is Section 5-5. It's standard form and intercepts, and what I'd like for you to be able to do by the end of this video is to define what an intercept is and to use them to graph a line. I'd also like for you to be able to write and graph equations in standard form. So, the first thing we need to do is cover a little bit of vocabulary. First of all, what is a y-intercept? What is an x-intercept? Let's talk about that again. So first of all, a y-intercept is the y-coordinate of a point where a graph crosses the y-axis. So you guys have been familiar with that before. It's where the line crosses the y-axis. Now we also have something called an x-intercept. An x-intercept is essentially the same thing, except now it's the x-coordinate that crosses the x-axis. So down here in this line right there, this point is my y-intercept, and this point right here is my x-intercept. So it's just where the line crosses one of the axes. Now, the formula for standard form, so this will be your third way to write a line, is ax plus by equals c. Now notice the a, b, and c are capital letters. So far we have y equals mx plus b. That's one form. We also have y minus y sub 1 is equal to m parentheses x minus x sub 1. And now we have our third form, which is standard form. So I'm going to highlight this because this is very important. And this is the third way we're going to be writing equations of lines. Now, how do you know how to calculate an intercept? Well, we're going to use the fact that when something is crossing the x or y axis, one of the values is going to be 0. So, or one of the x or y values, I should say. So every time you have a y-intercept, so 0 comma y would be the point, you set x equal to 0, then you solve for y. Every time you have an x-intercept, or x comma 0, you set y equal to, and I accidentally wrote it there, but here we go. We set y equal to 0, then we solve for x. So let's talk about how we do that. So we're going to try to figure out our x and y intercepts in this next example. It says, what are the x and y intercepts of the graph? All right, let's do y-intercept first. A y-intercept is going to have an x value of 0. So I'll write that up here real fast. Y-intercept has x equal to 0, and then an x-intercept has y equal to 0. That's the main gist of what we're doing today, this right here. Y-intercepts has an x equal to 0, x-intercepts has a y equal to 0. So if we want to do y-intercept right here, I'm going to put a 0 in for x. So now I'm going to have 3 times 0 plus 4y is equal to 24. Well, 3 times 0 just goes away. It's not there anymore, so I'm just going to cross it out. And now I have 4y is equal to 24, and I want to solve for y. So I'm going to divide by 4 on both sides, and I get y is equal to 6. My coordinates, therefore, are 0, 6, because remember, I'm finding an x and a y value. So my y-intercept is 0, 6. If I'm doing my x-intercept, then I want the y to equal 0. So what I'm going to do, I'm going to replace this y with 0. So I'm going to say 3x plus 4 times 0 is equal to 24. Well, now 4 times 0 goes away because that's just 0. And now I'm at 3x equals 24. Divide by 3 on both sides. X is going to equal 8. Okay. X equals 8 when y equals 0. So my coordinates are 8, 0. And that's all it wanted to know. So this is my y-intercept and this is my x-intercept. Let's do it again. So let's find y-intercept first. which means I'm going to set the x equal to 0. So I'm going to say 5 times 0 minus 6y is equal to 60. 5 times 0 is just 0, so it's not there anymore, basically. Now I have negative 6y is equal to 60. I'm going to divide by negative 6 on both sides because I want to get y all the way alone, and I get y is equal to negative 10. My coordinate, this is not my final answer. This is just part of a coordinate. My final answer is the 0 and the negative 10 put together as an ordered pair. So it's going to be 0, negative 10 for my y-intercept. I'm going to tell you what, I will highlight where those things are just so you can see them a little easier, hopefully. Let's do x-intercept now. For the x-intercept, I need the y to be set to 0. So it's going to be 5x minus 6 times 0 is equal to 60. 6 times 0 equals 0, so it cancels out. And now I have 5x is equal to 60, so I'm going to divide by 5 on both sides. X is equal to 12. My coordinate now, this is my x equals 12. This right here is my y. I set y equal to 0. So now my ordered pair is 12, 0. Alrighty, let's do one more. Let's do y-intercept first. For our y-intercept, we need x to be 0. So it's going to be 3 times 0 plus 8y is equal to 12. 3 times 0 goes away. So now I'm going to divide by 8 on both sides. Now this isn't going to give me a perfect number, and that's okay. What does 12 over 8 reduce to? Notice that I can divide a 4 out of top and bottom of that fraction. So I'm actually going to get y is equal to 3/2. Just leave it top heavy, that's fine. But my ordered pair is now 0, 3 over 2. Now let's go to the x-intercept. Now remember, when I have an x-intercept, the y value is going to be 0. So I'm going to replace y with 0, and that gets me 3x plus 8 times 0 is equal to 12. 8 times 0 is just 0, so I cancel it away. And now I have 3x is equal to 12. Well, I want to divide by 3 on the left and right sides, and I get x is equal to 4. Once again, I need an x value and a y value to have a coordinate. So in order to get that coordinate, I need the 4 for the x and the 0 for the y. And that's how you're going to calculate intercepts when things are in standard form for you. Okay. What if something is currently in standard form and we want to graph it? You have a number of strategies that you can use. One strategy is to completely rewrite your problem so that it is in slope-intercept form. You can turn it into y equals mx plus b. That's one option. You can also easily calculate the intercepts like we've just done. And once you have 2 points of a line, you can graph the line. So you only need 2 points in order to graph a line. And we can easily calculate 2 points with these equations by finding our x and y intercepts. So let's set x equal to 0 first. So if x equals 0, then it's going to be 0 minus 2y is equal to negative 2. So I was just using this formula right up here, and I'm showing my work below. Well, 0 minus negative 2, the 0, it doesn't matter. So I'm going to divide by negative 2 on both sides, and I get y is equal to 1. So now one of my coordinates is 0, 1. That's 1 point. What if y equaled 0? Well, if y equaled 0, then it would be x minus 2 times 0 is equal to negative 2. These completely go away because 2 times 0 is just 0, so now I get x is equal to negative 2. So my ordered pair is negative 2, comma, 0. All right. Now I have 2 points that I can easily plot on my coordinate plane. So the point 0, comma 1 is left and right none, up 1. And then the point negative 2, 0 is backwards 2 and then up and down 0. And I'm going to then connect these 2 points. And there's my line. Let's do that again over here. Once again, you can absolutely convert this into slope-intercept form if you choose, but I personally feel like we can easily find the intercepts. So I'm going to say if x equals 0, then it's going to be 2 times 0 plus 5y is equal to 20. I'm just pulling that straight from my equation up there. So now I'm going to divide by 5 on both sides, and I get y is equal to 4. So my first coordinate that I can graph is 0, comma 4. What if y equaled 0, though? That would be 2x is equal to, 2x plus 5 times 0 is equal to 20. 5 times 0 is just 0, so those go away. I'm going to divide by 2 on both sides because I want to get this x all the way alone. So now I get x is equal to 10. But I need my ordered pair, so it's going to be 10, comma 0. Let's plot those on our coordinate plane now. So 0, comma 4 is left and right none, and then up 4. 1, 2, 3, 4. 10, comma 0 is going to be to the right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Barely on the graph, but it's on there. And then up and down none. Then we connect our points. And there's our line. Now, what if you have a line that goes straight up and down or perfectly side to side? There are a couple strategies that you can use. You can think and just like memorize that x equals a number is going to be a vertical line and y equals a number is going to be a horizontal. You can do it that way. Or you can quickly set up a table of values and notice what my equation is. It is x equals 3. So I know no matter what y is, x has to equal 3. And then we can just list some y values. It could be 1, it could be 4, it could be negative 2, or it could be, 6. So now if we plot these points, we can then see if we can find a pattern. So the point 3, 0 would be over 3, up and down none. Then I have 3, comma 4, so it's over 3, up 4. 1, 2, 3, 4. 3, negative 2, so over 3, down 2. 3, 6, over 3, up 6. No matter what I put here, it's always going to fall on this vertical line right here. So when x equals a number, it is going to be vertical. Okay, now I have y equals a number. Well, if x equals a number is vertical, then y equals a number is going to be horizontal. So I can just go to y equals 3 right here and put a line through it. If you need to make a table of values, then that's okay too. So y just has to be 3, but what if x were negative 1, 0, or 3? So that would be like 3, 3, like this. And notice how they're all still falling on that horizontal line. So x equals a number is always vertical, y equals a number is always horizontal. Let's do a couple more on the next page where we're just practicing graphing that to remind you how that pattern goes, because I know it can be tricky because it feels like it's opposite. So I'll write it down again. X equals a number is going to be vertical. Y equals a number is horizontal. That is pretty important. I don't want you to forget those patterns. So I'm going to box it in for you. Okay. X equals 4. Well, we know it's going to be a vertical line, so I can just go over 4, 1, 2, 3, 4 right here, and then I can draw my vertical line through that. X equals -1. Because it's X equals a number, it is vertical. So now I'm going to go back to -1 and put a line through that as well. Notice these are not functions, but these next two are. Next I have Y equals 0. Okay, well, because it's Y equals a number, it's going to be horizontal or going left to right. So I am going to put that where Y equals 0, which is on the axis. Finally, I have Y is equal to 1. Well, when Y equals 1, it's going through this coordinate right here, and it's still a horizontal line. This is more so just a memorizing which one goes which way. And if it's hard for you to memorize that, then you can always make the table of values to kind of help back you up. We have one final example, and then we are done with today's notes. So example 4 is converting to standard form. What if I wanted something to be written in the form AX plus BY is equal to C? Now, please keep in mind that A, B, and C, they're capital letters to begin with, to kind of help us not get the B's mixed up like in slope-intercept form. All of these are going to be integers. In other words, no fractions. So, we need the x's on the same side as the y's, and then a plain number to be on the right side. So looking at this first one, notice I have y equals -3/7 x plus 5. I do not want my x on the right side. I want it on the left side of the equal sign, because notice right here it's on the left. So I am going to add 3/7 x to the right and to the left. And when I do that, they cancel. And then I have 3/7 x plus y is equal to 5. Already I have x plus y equals a number. X plus y equals a number. So this is already looking much better. The only thing I have to do now is get rid of this fraction. I don't want 3/7. So remember, I'll put a little note down here. To get rid of a fraction, multiply by the denominator. That's a big rule that we've been covering for quite a while. Okay, so the denominator here is 7. I'm going to take everything in that equation and multiply it by 7. So now that's going to get me 3x plus 7y is equal to 35. So it's like the distributive property. 7 times 3/7 x is 3x. 7 times y is 7y. 7 times 5 is 35. Now I have this of the form ax plus by equals 35. I'm good to go. Let's do this one. I do not like that I have x's on one side and a y on the other, and I have parentheses. This is in point slope form. I want it in standard form. So the first thing I'm going to do is distribute the parentheses. So I got y plus 3 is equal to 4x minus 4. Now I'm always referencing back to this. I want it to be in this formula. or in this setup way. So I need to get these x's to the other side. I'm going to subtract 4x from the left and from the right. And that gets me negative 4x plus y plus 3 is equal to negative 4. I also want all of my plane numbers on the right side, so I need to subtract 3 from left and right. And now I have negative 4x plus y is equal to negative 7. Now, the last thing I want to do is to make this negative 4 a positive because it's just a better way to write it. So I'm going to divide everything by negative 1, and I'm allowed to do that because if I do the same thing to both sides of an equation, I'm not breaking any rules. So now I have 4x minus y is equal to 7. And there's my solution. One more and then we are done. So I'm going to get my x's on the left-hand side because I want the x's first and then the y equals to a number. That is my form right here. So I'm going to subtract 1/4 x from the right and from the left. That gets me negative 1/4 x plus y is equal to negative 2. I do not want this fraction, so just like we said down here, to get rid of a fraction, multiply by the denominator. I'm going to multiply by a negative 4 in order to get rid of this negative as well, because a negative times a negative is a positive. So when I multiply by negative 4, I get x minus 4y is equal to positive 8. Negative 4 times negative 1/4 is positive 1. Negative 4 times y is negative 4y. Negative 4 times negative 2 is positive 8. And that is the end of our notes for today. I hope that this is making sense and that you have a great rest of your evening. Bye.